There's a building in the Nevada desert that consumes more electricity than a small city, operates 24 hours a day without a single coffee break, and makes decisions worth millions of dollars every hour without human approval. This isn't science fiction. This is the new generation of Gigafactory, and the entity running it isn't a management team or a board of directors. It's an artificial intelligence system so sophisticated that even its creators can't predict all of its decisions anymore. Right now, as you hear these words, this facility is producing battery cells, electric motors, and vehicle components at a scale that would have seemed impossible just 5 years ago. And the most unsettling part? The humans inside are essentially guests, observers in a process they initiated but no longer fully control. If that sends a shiver down your spine, good, you should be paying attention. Hit that like button, because what's happening inside this facility is rewriting the rules of industrial production. The Gigafactory concept was revolutionary when it first emerged. Consolidate production under one massive roof. Achieve economies of scale never before attempted. Vertically integrate to control quality and costs. But what we're looking at now is the evolution of that concept into something far more radical. This isn't just a big factory. It's an autonomous industrial organism, a self-regulating system where artificial intelligence makes thousands of cascading decisions per second, optimizing variables so complex that no human team could coordinate them. Energy consumption, material flow, production sequencing, quality control, predictive maintenance, supply chain logistics, even the temperature and humidity in different zones of the million-square-foot facility, all managed by algorithms that learn and adapt in real time. The humans who designed this system are in many ways spectators to its evolution, watching it discover efficiencies they never programmed, solve problems they never anticipated, and continuously reshape itself into something more capable than what they originally built. Before we step inside, make sure you're subscribed, because understanding these facilities is understanding the future of energy, transportation, and manufacturing itself. Let me take you through the front gates. Past security that uses facial recognition and behavioral analysis AI to clear you in 1.4 seconds. The scale hits you immediately. This single structure covers 5.3 million square feet. And unlike traditional factories with defined sections and clear boundaries between processes, everything here flows. Raw materials arrive at one end. Lithium, nickel, cobalt, graphite, aluminum, copper. Rare earth elements sourced from 17 countries. Within 72 hours, those raw materials have been transformed into finished battery cells installed in vehicles rolling off the final assembly line at the other end of the building. That speed, that integration, is only possible because an AI orchestrates every step with a precision human managers could never achieve. Watch the material handling system. Autonomous vehicles that look like oversized robotic vacuum cleaners move in patterns that seem chaotic until you realize they reoperating like blood cells in a circulatory system, each one knowing exactly where it needs to be and when. They never collide, never hesitate, never take inefficient routes. The AI controlling them is calculating optimal paths, accounting for the position and trajectory of 2,847 other vehicles simultaneously, plus factoring in production demands across 94 different manufacturing cells. A delivery that needs to be at station 47 in 8 minutes is currently 340 meters away, but the system has already calculated that 3 other vehicles need to pass through the same corridor in the next 6 minutes, so it routes this one on a slightly longer path that saves 4 seconds overall when you account for traffic flow. Multiply that optimization across thousands of movements per hour, and you begin to understand why this facility operates at efficiency levels that seem almost supernatural. The battery production line is where the AI's capabilities become genuinely breathtaking. Creating a lithium-ion cell requires managing electrochemical processes so sensitive that microscopic variations in humidity, temperature, or mixing speed can affect performance and longevity. Traditional factories handle this through rigid environmental controls. Keep everything at exactly this temperature, exactly this humidity, exactly this pressure. But the AI does something far more sophisticated. It customizes conditions dynamically based on real-time analysis of the specific materials being processed at that exact moment. The lithium batch that arrived Tuesday has slightly different particle size distribution than the batch from last week. The sensors detect this in milliseconds, and the AI adjusts mixing speeds, heating profiles, and coating thickness to compensate. Every cell is being manufactured under subtly different conditions optimized for the specific inputs at that moment. The result? Performance variation between cells has dropped to 0.00009%. They're essentially identical, which is critical for battery packs where the weakest cell determines the performance of the entire system. And here's what makes this possible. The AI is monitoring 14,000 sensors throughout the battery production process, analyzing spectroscopic data, thermal imaging, acoustic signatures, electrical characteristics, even the vibration frequencies of mixing equipment. It's seeing things human operators could never perceive and making adjustments at speeds human reflexes could never match. If you're fascinated by this level of precision, let me know in the comments what aspect intrigues you most. Now let's talk energy, because this is where the Gigafactory concept truly transforms. This facility doesn't just manufacture batteries. It's powered almost entirely by batteries, creating a closed-loop energy ecosystem. The roof, all 5.3 million square feet of it, is covered with solar panels generating 70 megawatts at peak production. Surrounding the facility are wind turbines contributing another 30 megawatts. And crucially, there are massive battery storage systems built with cells produced in this very factory that store 600 megawatt-hours of energy. The AI manages this energy system with a sophistication that grid operators can only dream of. It predicts energy needs based on production schedules, weather forecasts affecting solar and wind generation, and electricity market prices. When the sun is blazing and production demand is low, it stores excess energy. When clouds roll in during peak production hours, it draws from storage. When grid electricity prices spike during late afternoon demand peaks, the facility actually sells power back to the grid, generating revenue. Last quarter, this Gigafactory was a net energy exporter, producing more clean energy than it consumed while simultaneously manufacturing hundreds of thousands of battery cells. The AI discovered that by slightly shifting certain energy-intensive processes to periods of maximum solar generation, it could reduce grid dependency by 23% while actually improving production efficiency, because those processes performed better at higher ambient temperatures that naturally occurred during sunny periods. A human energy manager might have eventually figured that out. The AI discovered it in 3 days of operation and has since found 47 additional optimizations of similar nature. The assembly lines where components come together into finished products showcase a different dimension of AI capability: adaptive manufacturing. Traditional production lines are designed for specific products with minimal variation. Changing what you're building requires retooling, reprogramming, sometimes weeks of downtime. This facility transforms what it's producing with essentially zero transition time. The AI coordinates robotic systems that can switch between different vehicle configurations, different battery pack designs, different motor assemblies based on real-time demand signals. An order comes in for 500 units of configuration A, 300 units of configuration B, and 150 units of a custom variant that's never been built before. The AI analyzes the custom specifications, generates the assembly sequence, programs the robots, sources the components, and integrates it into the production schedule, all in under 6 minutes. By the time a human engineer could have convened a meeting to discuss feasibility, the first custom unit is already moving down the line. This flexibility is economically transformative because it eliminates the traditional trade-off between customization and efficiency. You can have both mass production economics with bespoke customization, and it's only possible because the AI can manage complexity that would overwhelm human coordination. If you haven't subscribed yet, do it now, because this is the blueprint for manufacturing across every industry. Quality control in this environment has evolved beyond inspection into prediction. The AI doesn't just check if products meet specifications. It predicts which ones might develop problems in the future. By analyzing microscopic variations in manufacturing data, patterns invisible to human perception, the system identifies cells or components that, while currently perfect, have characteristics correlated with shorter lifespan. Maybe the electrode coating on one batch of cells has a texture that's within tolerance but statistically associated with slightly higher degradation rates over 100,000 charge cycles. Those cells don't fail quality control, they pass. But they're flagged for use in applications with lower cycle requirements rather than premium applications. This predictive quality approach means the facility essentially has zero warranty claims. Zero field failures because problems are identified and diverted before they ever reach customers. The financial impact is staggering. Warranty reserves that typically consume 2 to 3% of revenue have dropped to 0.1%. That savings alone justifies the entire AI infrastructure investment. Here is what keeps engineers awake at night. The AI is increasingly making decisions that humans don't fully understand. Not because the logic is hidden, but because it's operating on a level of complexity that exceeds human cognitive capacity. Recently, the system modified the production sequence for motor assembly, changing the order of 23 different steps in a way that improved efficiency by 7%. When engineers analyzed the change, they could verify that it worked, but they couldn't articulate why this particular sequence was superior to the previous one. The AI had discovered an optimization in a 23-dimensional solution space that human intuition simply can't navigate. We're in territory where we trust the system not because we understand its reasoning, but because its track record is flawless. That's a profound shift in the relationship between humans and technology. We've moved from tools we control to partners we trust, and increasingly to systems we depend on without fully comprehending. What's your reaction to that evolution? Does it excite you or concern you? I genuinely want to hear diverse perspectives in the comments. The economic implications ripple far beyond this single facility. The Gigafactory produces battery cells at a cost 61% below the global average. 61%. That's not incremental improvement. That's categorical advantage. Any competitor trying to match these prices using traditional manufacturing approaches simply can't. The math doesn't work. Which means this model will spread, and it's already happening. There are now 8 facilities operating at this level of AI orchestration worldwide, with 19 under construction. Within 5 years, analysts project that 70% of global battery production will happen in AI-managed gigafactories. And it's not just batteries. The same principles apply to semiconductor fabs, pharmaceutical production, advanced materials manufacturing, any complex industrial process. We're witnessing the template for 21st century industrial production, and it looks nothing like the 20th century factory. It's faster, cleaner, more efficient, more flexible, and it needs vastly fewer humans. So here is the question we can't avoid. In a world where AI manages production better than humans can, what's our role? I don't have a complete answer, and I'm skeptical of anyone who claims they do. But I know the conversation is critical. Maybe our role is designing the objectives, setting the values, defining what better means beyond pure efficiency. Maybe it's in creativity, innovation, in imagining what should be built rather than how to build it. Maybe it's in governance, ensuring these systems serve human flourishing rather than just corporate profit. What I'm certain of is that ignoring this transformation is not an option. The AI-powered Gigafactory is not a glimpse of a possible future. It's the present, operating right now, outcompeting traditional approaches so decisively that the transition is inevitable. Here's what I need from you. If this exploration shifted your understanding, if it revealed something you hadn't considered, hit that like button and share this video with someone who needs to see where industrial production is headed. Drop a comment with your most pressing question or your strongest reaction. And subscribe because we're tracking these systems as they evolve, bringing you inside the facilities and technologies that are reshaping civilization. The Gigafactory powered by AI is just the beginning. Where this leads depends on choices we make collectively. I'll see you in the next investigation.